This is a lesson on 10.2 regression by Avinash, Yovan, Rahul, Liam, Michael, and Krishnik. This is the terminology for 10.2. A residual is the difference between the actual value of y and the predicted value of y for a specific value of x. A regression line is the line of best fit of the data. The best fit is when the sum of the squares of the vertical distances from each point to the line is at a minimum, and this enables researchers to see the trends and make predictions on the basis of the data. A marginal change is the magnitude of the change in the dependent variable when the independent variable changes 1 unit. Extrapolation is the magnitude of the change in the dependent variable when the independent variable changes 1 unit. An influential observation is an observation that when removed from the data values would markedly change the position of the progression line. And here is the formula for the regression line y apostrophe equals a plus bx. And below is the steps to find the regression line equation. You make a table, find the values of x times y, x squared, and y squared, and place them in the appropriate columns, and find the sigma, or sum, of each column. When r is significant, substitute in the formulas to find the values of a and b for the regression line y apostrophe equals a plus bx. This can be applied to economics because it can be used to analyze the connection between variables to find patterns by using residuals and lines of best fits. Specifically, it can be applied to the U.S. per capita GDP to understand the trend of the economy. A line of best fit can be used to understand the slope, increasing or decreasing. Finding correlations between factors such as interest rates, employment rates, and consumer spending and inflation, and it can also be used in predictive analysis to forecast future economic conditions based on historical data, such as if we're going to have an economic recession or depression. Our first example is the gestation period and the longevity of the lifetime of animals in years. We have to find the equation of the regression line, find the y apostrophe value when x is equal to 185. Our first step is constructing a table of the formulas. Next is solving for the y-intercept and the slope, which is a and b respectively. You plug them into the respective formulas and you get your values. After that, you make a final equation for each and plug in x to solve. In which case our answer for this is, for y apostrophe, is y equals 21.723. Example 2, much of the same. Create a chart if you're given a chart of your data values, create the table for the formulas, substitute in your values to solve for the y-intercept and slope. And then in this equation, we are asked to make a graph. So plug the values into our equation and then insert the graph into your graphing calculator. Example 3, we need to find the regression line and the y apostrophe value when we're given x from this graph of values. Our first step is to construct a table using the points provided on the graph, then construct a table for the formulas, and then solve for our y-intercept and slope values. After that, for step 4, we find our y apostrophe formula, and then we can find what our y apostrophe is equal to when we substitute x for 10, which is 3.596. Now, the fourth question we need to answer is how can regression be applied to the mung bean germination experiment? And specifically, we can apply this by constructing a regression line to determine what pH, to determine a best fit, so we can use that line of best fit to predict where the data might go, such as what is the best pH for germination, what is the worst pH for germination, using this regression method. Thank you for watching.